Hello everyone, this is the fourth video of Chapter 3, Slope-intercept form. In this video, you can identify linear equations using the slope and y-intercept by using the slope-intercept form. Before I begin with the slope-intercept form, let's review what we talked about in the previous lessons. The slope. In a variable, we are using the m, where the slope is written by rise over run. Also, the rise is representing a vertical change over a horizontal change. When we're looking at the direct variation, we looked at it as m is equal to y over x. So far, the slope can be found in many different ways. And besides on these forms, also there was one more, the y equals mx form. So when you are given with the equation y is equal to a number x, we can find this number right here, the m, will be your slope. So let's look at what it means by slope-intercept form. This is a format that is fixed that we're going to use. Any non-proportional linear relationships can be written in the form y is equal to mx plus b, where the m is the slope and b is what we call y-intercept. So in here, we are going to practice how to define which number will be representing the slope and which number will be representing the b value. Our example in this lesson, we'll be looking into how do you know which number will be representing the slope, which number will be representing the y-intercept. Just to be a little ahead of our practice, any slope will be containing with the x value. So when you're writing the m, this number has to be always in front of the x, where the y-intercept does not contain any x value. They are being separated by either addition or subtraction. State the slope and y-intercept of the graph of the equation y is equal to 2/3 x minus 4. This is a slope-intercept form followed by y equals mx plus b form. So in here, if I try to match them, the y on the left side is the same, the y is y, but the m, instead of m in here, I notice I have 2/3. So my m will be 2/3 in this case, where b is representing -4. The reason I'm counting this negative is because when you are looking at the form, you begin with plus b. But because your b is -4, when you have plus -b, they will simplify this and saying, oh, this is just -4. So in here, my slope is equal to 2/3, and the y-intercept becomes 4. Let's do a couple more examples. What if you have an equation y is equal to -5x plus 3? In this case, again, you're following the slope-intercept form. Y is equal to mx plus b, where the m is represented by, this time, -5. You need to carry your sign as well, so the m is the whole number, -5. Then b becomes 3, where this time, as you see, the positive stayed positive. So you don't have to worry about negative sign this time. You just say b is equal to +3. For the next problem, when I'm looking at the order, it looks like, again, y equals mx plus b form. So the m is going to be 1/4, that's the slope. And for the b value, the y-intercept in this case will be -6. The whole number will be here, -6. When I'm looking at the part C, y is equal to -x plus 5. In this case, I don't see any number in front of the x, but there's just negative. So you can write this one as y is equal to -1x plus 5. My m value in this case will be -1, that's my slope, and then the y-intercept is equal to 5. Unless you are being instructed specifically, it doesn't really matter to me how you write it. Sometimes I spell it out, slope, sometimes I just write m, sometimes I just draw the points. Number 2, write an equation of a line in slope-intercept form with a slope of -3 and y-intercept of -4. So this time I'm going to do backward. I'm going to write an equation format of slope-intercept form. So y equals mx plus b format, where I need to know what they are representing. In here, I'm going to circle the two values. The one is m, the one is the b. The reason I'm circling this is because these are the only variable that I need to replace with a number. So m is the slope, where b is representing your y-intercept. Now, when I'm looking at the number, they told you the slope will be -3. So if I put -3 in here, and the b becomes your y-intercept -4, if I write the equation, y equals -3x plus b, where I don't have to write plus because eventually you're just going to write y is equal to -3x minus 4. So that's how you're going to finish the problem. Y is equal to -3x minus 4. Number 3, write an equation in slope-intercept form if you were given with a graph. So same thing, if I'm going to write slope-intercept form, I'm still going to use the format y equals mx plus b. In here, again, I need to circle the two variables. The first one is m, the second one is a b. These are the two variables that I just need to replace with a number. In order to find the m, that's your slope, if you want to find the slope, I'm going to use rise over run, where in this case, I noticed they already picked the 2 points from the graph, and it looks like they're going from here to the second point. So as you see, my point is going down from this one to here. So my rise, the vertical change of your y value, even though it's just 1, I need to write as -1. And then for the running part, from this point to become the second point, I'm running 2 units, so it becomes +2. Where the b value, the b was representing the y-intercept. The y-intercept can be easily found on your graph by looking at the y-axis. This line right here, I'm trying to find when is my graph intersecting with that line. It looks like they are intersecting at the point of 0, 4 right here. So they're actually telling you right here the y-intercept is 4. Let me just erase it a little bit so that you guys can see it better. So I was looking at the y-axis right here compared with the graph. In this case, if I rewrite the equation a little bit nicer, right? Y equals your slope was -1/2, and then keep the x because you're not changing this with any number. And then when you had y-intercept with a 4, I'm going to write +4. And that's how you end the problem. The next problem, write an equation in slope-intercept form of the graph shown. If I want to write the slope-intercept form, I begin by writing the format y equals mx plus b. In here, there are 2 numbers that you need to be replaced with. The first one is the m, the second one is a b, where m is your slope, b is your y-intercept. To find the m value, let's do rise over run. So it looks like they already picked 2 points for you. Here's 1 point, and here's the second point. It doesn't have to be this one. You can pick any other point as long as it's at the corner. However, by looking at this graph, it doesn't really look like you have a clear point. You have to probably guess what this number would be, but I don't want to risk it. So here, if I want to count how far I'm rising, I'm going up. 1, 2, 3, 4, 5 is my rise. Over the run part is from here to get to that point. I'm running 1, 2, 3. That's going to be my slope. For the b value, again, that's going to be your y-intercept. The y-intercept can be found when you are looking at the graph with this y-axis. When is these 2 lines are intersecting? That's what you're looking for. In this case, it looks like they're intersecting at this point right here. This point is at 0, -2. My y-intercept becomes -2. So that makes my answer to be y equals 5/3 x minus 2. Part E becomes, write an equation of a line in slope-intercept form with a slope of 3/4 and y-intercept of -3. So again, let me start by y is equal to mx plus b. What were the 2 things that I'm going to circle? 2 variables, m and b. This one is slightly easier than the part D because they're telling you what is the slope and what is the y-intercept right away. You don't have to look for it. So the m in this case is the slope. The slope is 3/4. They're saying the y-intercept of -3. So it goes on here. And then I can just write my answer as y equals 3/4. Remember the x will change. Plus -3 will become just -3. And that's the answer of this problem as well. When an equation in slope-intercept form applies to a real-world situation, the slope represents the rate of change and the y-intercept represents the initial value. Later, I also refer it as the starting point. So this is very important that you might want to write it down. The y-intercept is a starting point. Slope is a rate of change. Here's an example, number 4. Student Council is selling t-shirts during the Spirit Week. It costs $20 for the design and $5 to print each shirt. The cost y to print x shirts is given by y is equal to 5x plus 20. Graph y equals 5x plus 20 using the slope and y-intercept. Knowing that it is following the slope-intercept format, y equals mx plus b. I could find the slope in here will be, which number? 5. The y-intercept would be 20. So let's graph this problem using slope and y-intercept. They're saying if I have a graph, I'm going to draw a little sketchy, x, and the vertical line will be your y value. The x is representing, they're saying, the shirts, so I'm going to say number of shirts, and the y is the cost to print, so I'm going to write $sign. Slope is 5, y-intercept is 20. When I graph using the slope-intercept form, I always begin with your starting point. What is your starting point in this case? Referring back to the point, they were saying the y-intercept is the initial value, another word of the starting point. So I'm asking you, what is your y-intercept in here? That's going to be what you begin with. So here it looks like I'm going to draw 20. So 2, 3, 4. Let me just write this one. It's going to be 20. Then I'm going to draw the point. So here's a point at 20. And they're saying I need to use the slope. The slope, we are going to use what we learned earlier, rise over run. So if the slope is 5, what I want to do is I want to make this as a format of rise over run. Another word, a fraction. If I want to make 5 as a fraction, we're going to put 1 on the denominator. So 5 over 1 is still 5. I'm not changing my number because 5 divided by 1 is still 5. So which means I'm rising 5 over I'm running 1. So anytime when I rise 5, I just realized that my graph should be a little bit bigger. So let me erase this part on here. And then let me continue. I graphed my y value as scale of 5. So 5, 10, 15, 20. So when I'm going up 5, I get 25. So over here. And then I was at 0 and I'm running 1. So here's another point. And at 2, if I follow the same concept from 25, when I rise 5, it's going to be at 30. So, and if you connect them, you would see a beautiful graph right here. And then you can just continue as much as you want. It can take all night if you would like to. And I stop right there, and there's a graph. Number 5, interpret the slope and the y-intercept. What they're asking here is, what does your slope and y-intercept meaning in this situation? The slope, the 5 was the cost for each shirt, but for the y-intercept, this $20 was for the design. So it doesn't matter how many shirts you're printing, you just have to pay the $20 up in front. So this $20 is the design fee, and this fee you only pay once. And that's how I interpret my slope and y-intercept. Let's do just one more problem. A taxi fare y can be determined by the equation y is equal to 0.50x plus 3.50, where x is the number of miles traveled. The first part is asking you to graph the equation. So in order to graph the equation, well, let's see what does x and y represent. They're saying the x was representing the number of miles that traveled. Then the y was representing the taxi fare. So I'm going to say taxi fare in $sign. We are going to use the slope and y-intercept to graph. To graph, we are going to begin with the initial value, another word of your starting point. I need a point to begin with to use a rise over run. So the starting point will be your y-intercept. First, you need to know which number will be representing the y-intercept. Here's how I know. When I'm looking at two different numbers, the first number is indicating with the x, the second number doesn't. The number that doesn't have the x is going to be your y-intercept, so I know the starting point will be 3.50. Then we're going to use a slope, rise over run, becomes the slope is going to be then 0.50, so just 0.5 would be fine. The problem is this one doesn't really look like the rise over run form, so I need to make this one as a fraction. In order to make a fraction, I'm going to write 1 underneath. So in here, when I start with 3.5, so that would be in between 3 and 4 right here, 3.5. That's my starting point. From here, I'm going to use a rise over run. Anytime when I rise 0.5, I need to run 1. So in here, if I rise 0.5 from 3.5, I get 4. And when I run 1, here's a point. So in here, I could actually just draw the line and be done with it because I could graph a line. However, if you want to be more accurate, I suggest you continue with a few more points. So from here at 4, if I rise 0.5, I get 4.5. So I'll run here. But then I need to run 1. So if I run 1, it's going to be over here. And same thing, from 4.5, rise 0.5, and then run 1. There is the point. So compared with the other graph that I saw, this will be a little bit more accurate, as you see. And then I normally draw an arrow at the end saying that this could be continued. Part G, interpret the slope and the y-intercept. Where slope was 0.50, this is representing a 50 cents per miles is a rate of the taxi fare. And then 3.50, that is your y-intercept. So $3.50 is a flat rate. Doesn't matter how far you're traveling, you always have to pay $3.50 for a flat rate. So this is the end of the lesson. Thanks for learning with me. If you have any questions, please don't hesitate to leave a comment.